Hello, everyone. Welcome. My name is Sid. I'm a principal solutions architect here with AWS, and you are watching the Routing Loop. This is our weekly series where we talk about everything AWS networking. And today we have a special one for you. So, we are talking about centralized inspection architectures. So, all of you network engineers and architects who are deploying your critical workloads on AWS, you must be thinking, how can I secure all of this? How can I secure all my network traffic? Where do I deploy my firewalls? Whether it's distributed, whether it's centralized? Should I be using AWS Network Firewall? Should I be using something else? Well, we are here to answer all of those questions. And to do that, I have very special guests. I have Mehdi and Joe joining us, who also are part of AWS. I'll let them introduce themselves and kick off today's session. So, Joe, Mehdi, up to you guys.
Okay, so my name is Joe Flanagan. I am a senior network specialist with AWS. I'll turn it, Mehdi, you can introduce yourself there.
Hi, everyone. My name is Mehdi Dahan, and I'm also a senior network specialist at AWS. I'm based in London.
So today we're here to talk about network inspection, key insights, lessons learned. Over the years, we at AWS have worked with our customers. We've listened to some scenarios, questions on designs, issues, even blockers, and we work with them to come up with solutions to these issues. Um, and so what we've done here is we've compiled them as key insights, as lessons learned. The hope here is that you'll take this education back and apply it to your cloud inspection deployments. So real quick on the agenda today, we're going to talk about AWS Network Firewall or firewall appliances, centralized versus distributed model, pros and cons for each, and then we'll go a little bit deeper into ingress. From there, we will talk appliance mode, where you should use it, where you should not use it, and we'll talk with bandwidth considerations as well. Next, who doesn't want to save money? We'll talk understanding cost and chargeback, and then we'll jump into cloud WAN service insertion. Almost a year old, I guess now. It's a new feature which helps you greatly deploy your inspection in cloud WAN. And then we'll close it out with managing firewall policy and logging and monitoring. So I'll turn it over to Mehdi.
Thanks, Joe. Um, and thanks, Sid, for having us on your show. So, hello, everyone. So, as we mentioned earlier, Joe and I are both network specialists, right? So, our role means that we get to work with different customers on their network, right, and how to deploy networks in AWS. So we get to see firsthand what works best for customers. So the idea here is, we bring that back to you and share some of the learnings and insights that we had from that. So one of when you start thinking about network inspection, one of the first questions that comes up is from customers is, shall I use AWS Network Firewall, or shall I use like a virtual appliance of whatever firewall I have in my data centers or on-prem? I guess so. We thought we're going to start the conversation here, and I guess there is like the answer very much depends on situation, the customer, and what are their priorities. So here I'm sharing with you some of the main aspects that customer take into account for selecting one or the other. So on the left, you got the AWS Network Firewall, which is a fully managed deep packet inspection firewall that gives you IPS as well as web filtering. You can look at your TLS traffic, decrypt it, inspect it, and then re-encrypt it again. So you got inspection of encrypted traffic, and very importantly, it's the managed service, right? So we got all the benefits that come with that, including the high availability, the scalability, the APIs that come with it. So you could very easily integrate it with your CI/CD pipelines for deployment. And that's something that I see often tilt the balance, and customers tend to love it. Then you got like obviously central management, and we have a whole ecosystem of partners that we're going to see on the next slide. On the other hand, on the right side, we've got gateway load balancer with our partner firewall appliances. So the reason we see customers selecting that route is usually because sometimes it's required by the enterprise standard, right? And the standards say we want to use the same firewall everywhere because we vetted that firewall, or it could be because they want to integrate it with an already existing management platform, and manage the firewall on-prem and the firewall in the cloud via the same tool, or it's just because the teams are used to them, right? And they're familiar with the type of firewall. However, when you deploy this firewall, just keep in mind a couple of things. One is that you have to manage the EC2 infrastructure that goes with that, as well as the software update and licenses, because it's not a managed service, right? As well as the costing comes with the licensing, the EC2, and the gateway load balancer as well. I just want to mention, though, however, that there are some partners that now offer like a managed version of their firewall, like a fully managed version. In terms of feature parity, it's not 100% there, but the solution exists. So both approaches are fine, and we see customers doing both. Selection depends on the specific use case. So here's like a quick list of the kind of partners that integrate with the network firewall on the left, in terms of like threat intelligence or policy management or analysis. And on the right, you see like the partners that have developed the integration with the gateway load balancer. All right. So the next question that always comes up and that we have to answer is, which deployment model shall I go with? Shall I go with centralized or distributed? So what do I mean by that? So a distributed model is where you deploy a firewall in each VPC, right? So each VPC that you have will have its own firewall, right? Especially for egress and ingress. Whereas with centralized model, you take that firewall, deploy it in its own VPC, and then direct the traffic via Transit Gateway or Cloud WAN to that centralized inspection VPC. And so let's explore the two options and what are the benefits and pros and cons of each. So let's start with distributed. So I mean, you would use distributed because maybe you want to give more responsibility to the application owners or VPC owner to manage their own thing, right? So it's easier in terms, you don't have to worry about routing it to some central VPC and so on. So there are reasons why you would want to deploy distributed. However, the main challenge with this approach is the cost, right? So let's just explore where that cost comes from. So the first thing, you've got NAT gateways everywhere, but the NAT gateways cost will be offset by the network, by AWS network firewall cost, right? So if you have NAT gateway and network firewall in the same account, you're not paying for NAT gateway, you'll be paying for the network firewall only. So that's not that. Again, is it traffic processing that's going through the firewall? So whether it's distributed or centralized, it's going to be the same amount of traffic going through to the internet and hence through your firewall. So the difference is not there. The difference comes from the number of firewall endpoints that you deploy, right? So there is a charge, which is like an hourly charge per firewall endpoint per availability zone in each of your on your VPC. So here I've given an example for 10 VPCs with 3 AZs and 100 VPCs with 3 AZs, and then you can see that the costs could quickly go out of hand if we have like a more than 100, 200, 1,000 VPCs in some of the customers that we work with. The other thing is with this distributed mode, something I wanted to point out is that each network, each AWS network firewall is an instance by itself. So you're going to have multiple firewall instances. This is not a big problem because you could apply the same policy across a number of firewall instances. A benefit of this approach is that you're not sending any of your internet traffic through your transit gateway because it's not centralized. So you're not paying that cost of the transit gateway. However, if you want to do east-west inspection, there is no really efficient way of doing it with distributed model. You still have to centralize the east-west inspection anyways.
So Mehdi, a quick one. You mentioned east-west inspection. For some of our audience members who don't understand the term east-west, can you explain what that
Okay.
is?
So east-west is the traffic that remains sort of within the cloud that is not going to the internet and back. So if you're going from one VPC to another, that would be considered east-west. So and the traffic going to the internet and back, that's what we call north-south traffic.
Awesome. Thank you.
So
And folks, we are monitoring chat. So if you have any questions, feel free to put them in chat. We'll have a look at them and we'll bring them up as appropriate.
cool. Feel free to interrupt me, Sid, for any questions.
Absolutely.
So the previous slide was for using the AWS network firewall, but similarly, we can have like a distributed approach with a third-party firewall with gateway load balancer. So in this case, we will have to put the firewall somewhere because it's not a managed service, so they will have to live in a VPC with the gateway load balancer. But we can deploy gateway load balancer endpoints like you see in the VPCs themselves. So in this case, the gateway load balancer endpoint is going to be have a lower cost than the firewall endpoint because it doesn't come with the firewalling features, because those firewalling features are covered by your firewall license in this case, whereas before there is no license. It's just covered by the firewall endpoint, right? However, what you need to take into account is when you do this approach is that the NAT gateway cost is not offset, right? So you end up paying for NAT as well, including the hourly charge for NAT gateway, the data processing of NAT gateway, as well as the charge of IPv4, right? Here again, we're not sending any traffic, any internet-bound traffic via the transit gateway or Cloud WAN. And again, the east-west inspection going between VPCs will still need to go through a central inspection point. So that's for distributed. Now let's look at centralized and its benefits. So when I speak about centralized here, I'm talking about centralizing egress, that is traffic going to the internet, and east-west traffic going between your VPCs. For ingress traffic, i.e. traffic coming from the internet into your public-facing application, for instance, I'm going to cover that on the next slide, right? So if with centralized, we're deploying like a VPC, we putting the firewalls and the NAT gateways in it, and then we route all the traffic going to the internet or east-west via this centralized inspection. Because we're deploying together with the NAT gateway in the same account, then again, the NAT gateway is offset, right? Meaning there is no charge for the NAT gateway, or it's covered by the charge of the firewall, right? And then most importantly, in this case, because we have a single firewall with just, we're going to have like let's say three endpoints, each endpoint in one availability zone in that single VPC. No matter how many VPCs we've got on the left, the cost of the firewall hourly charge will be the same, right? So we can have 10, 100, 1,000 VPCs on the left there, and the firewall hourly charge will not change. And believe me, that makes a huge difference for a lot of our customers. It's a single network firewall instance in this case. We're just managing one firewall, but it's a managed service, so therefore it's highly available and scalable and all that. But the question that you might have, you say, hang on, Mehdi, a second. In this case, we're sending traffic via the transit gateway or Cloud WAN, right? So there is a charge anyway for sending traffic via Cloud WAN on transit gateway. The answer is yes, yeah, but it's still like here I'm giving an example for 1 terabyte of traffic that you're sending through transit gateway back and forth to the internet is going to cost you like $40. So it's still like not very significant compared to the cost of deploying firewalls that we saw earlier in each of the VPCs. However, centralization brings some other consideration, including like bandwidth, because at the end of the day, we're putting a lot of traffic through that single VPC. The size of the policy of that firewall, and then role and responsibilities as well. We're going to talk about this in a bit. Now I mentioned we're going to talk about ingress. So we said centralized egress going to the internet and east-west. For ingress, the recommendation and what we see works best for most of our customers is to keep it distributed. Why? Because you allow your developers, your application owners to manage the entire stack, right? And I'm going to show you what other alternatives are there and what are the implications. So let's say we keep it distributed in that way, but we have to secure it, right? One thing that you'd notice is traffic coming from the internet, inbound traffic, tends to be for the majority web traffic, so HTTP or HTTPS, right? I want to say I don't have the actual statistics, but maybe it's 95% of the traffic is going to be HTTP or HTTPS. And what's best to protect HTTPS traffic is to put a WAF in front of your internet-facing applications, which can be with one click assigned to, with AWS WAF especially, you can just, there is a one-click attachment to like an ALB, which is an application load balancer, as well as CloudFront distribution or an API gateway. To that, you want to add like some DDoS protection. So for DDoS, AWS has AWS Shield, which comes in two flavors. So you got AWS Shield Standard, which is enabled by default for all AWS customers, and you got Shield Advanced, which allows you to protect against like larger, more sophisticated attacks and gives you like access to AWS Shield Response Team 24 hours 7, and gives you like charge protection in case of a DDoS incident for your ALBs and EC2 instances if they happen to be impacted. The other thing that I see customers do wanting to deploy firewalls on egress is because they need to manage their instances, right? So they tell me, "Hey, Mehdi, I need to get SSH, I need to RDP sometimes into my instances, and therefore I need like some sort of firewall there." However, I just want to point out that we in AWS we have a solution for that we call EC2 Instance Connect, which I invite you to go check, which allows you to authenticate the users coming in and securely allow them to get into their instances. So if you still want to deploy network firewall, you still can. So you can deploy it in a distributed fashion, like by inserting it like this like I'm showing in VPC 1, or you can centralize it. But when you centralize it, there are a couple of considerations that you need to take into account. One is that your public-facing load balancers will have to be deployed in a central inspection VPC, right? If you're centralizing it, and therefore comes the question of who's managing them, who's deploying them. Is it the application owner? Is it the inspection VPC owner? How are you going to do? How are you going to do that? The other thing is when you deploy a load balancer in one VPC and your targets are in a different VPC, the only way to get to them is like to have IP-based target groups. You can't do like instance-based target groups, for instance, and you lose the ability to use auto-scaling groups. So to avoid that, what we see some customers do if they want to do centralized is to deploy a network load balancer in the target VPC and point the application load balancer to the network load balancer IP address, and then the network load balancer will point back to the instances. So in this case, you'll have two load balancers to manage, right? So if you really want to do centralized or like insert like a firewall in a distributed way, there is a way. However, what we see works best is to keep it with the WAF and Shield and Amazon CloudFront in front of your applications. So to summarize this centralized versus distributed, so it's not one or the other, it's both, right? So you centralize for egress and east-west, and you keep it distributed for your ingress. right? And all the security elements that are shown here, including network firewall, AWS WAF, AWS Shield, are managed, can be centrally managed with AWS Firewall Manager, which also can manage your security group, your ACLs, as well as your DNS firewall. All right.
So we do have a question in chat, but
Mm-hmm.
I'm just going to quickly bring it up.
Yeah, sure.
Um, it's related to Cloud WAN. I know, Joe, you're going to talk about Cloud WAN later in the session, so maybe it might be best covered in detail there. But I'll still sort of bring it up,
Yeah.
and maybe I'll take a stab at giving some guidance, and you guys can add on. So the question here is, when you are doing centralized inspection,
Mm-hmm.
we have east-west traffic inspection between prod and QA environments, and they're doing large data transfer between them. But the question here is, can we bypass this inspection for certain flows based on source and destination? So my understanding is, within Cloud WAN, when you're doing centralized inspection, the way you're inserting firewalls is based, especially if you're using service insertion, you're writing a policy saying between my prod and QA, inspect all traffic. Right? So the inspection is
Right.
based on a segment level. It isn't necessarily based on a source and destination. But you
Right.
could bypass using cloud. Like, we have seen a lot of customers who use the VPC peering, for example, where you have extremely large data transfer between two VPCs. And if you use VPC peering, and especially if the source and destination are in the same availability zone, you don't pay for data transfer charges. So you're saving a lot of money, right?
Yeah.
So for some use cases, you can actually bypass the use of Cloud WAN itself and just go use VPC peering. But I'm curious, Joe and Mehdi, if you have any other thoughts on that.
No, you're correct, Sid. So there's no microsegmentation right now. It's basically he mentions prod and QA. You're going to send all traffic from prod to QA and the return path as well. Your workaround's correct. If you have two VPCs that need to communicate, perfect. VPC peering is a perfect solution. You could create another segment and basically remove the traffic that you don't want inspected and put it in there, and then just not send it to the service insertion. But again, that's a little more admin overhead at that point. But yeah, today you can't do that.
Awesome.
Yeah.
We have one more question here. Mehdi, I think you can take this one. I think it's
Sure.
just a clarification. For the ingress, distributed ingress, was the
Mm-hmm.
recommendation to put a network firewall in each of these distributed VPCs or something else? Can you just recap that recommendation there?
Yeah, sure. I think the recommendation is what's on the picture here, essentially, which is the summary. So what we're saying is, for ingress, the recommendation is not to put a network firewall in front of your web traffic, right? If it's HTTP traffic, you don't need to put it. You can use AWS WAF combined with AWS Shield. You might want to have AWS CloudFront distribution as well. So the recommendation, what we see customers do very often, is this: what you're looking at the screen.
Awesome.
Yeah, cool. And then, so centralizing brings some considerations, I should say. So I want to talk about something called appliance mode and bandwidth consideration. So appliance mode is something that a lot of people are familiar with, but I just wanted to cover it because I notice when I talk to a lot of customers, it's not fully 100% understood. So I thought I'll cover it quickly, just to make sure we're all on the same page when it comes to that. So appliance mode is something that you need to enable when you deploy stateful devices in your environment. So what it does is ensure that forward traffic and return traffic land on the same firewall. Because if forward traffic lands on one firewall and then return traffic end up on a different firewall, then that traffic is dropped, because that firewall did not see the forward traffic in the first place. So appliance modes make sure that symmetry is maintained. So when you deploy an east-west inspection, and this applies for east-west, or if it's east-west is combined with egress as well, because often we combine east-west and egress into one VPC. But as long as you've got east-west in that VPC, you would need to enable appliance mode on that attachment between the inspection VPC and your TGW or Cloud WAN, so Transit Gateway or Cloud WAN. And you need to enable it on that attachment only. No other attachment will need to have appliance mode, because I see sometimes customers get confused and enable it in different places. It's only that attachment that will need appliance mode. So the way appliance mode works is, as you see, like forward traffic, it will pick one AZ, we send the traffic, and then return traffic, if you see, even though it's coming from AZ2, TGW and Cloud WAN will ensure that it's going to go back to the same firewall. So it uses like a flow-based hash mechanism to do that, and disables what we call AZ affinity, that is by default in Cloud WAN and TGW. And AZ affinity means if TGW receives traffic from AZ1, it will prefer to send it to AZ1. So if you look at the bottom, if we didn't have appliance mode, traffic coming from AZ2 would have landed in AZ2 in the inspection VPC. And that's what appliance mode does for you. So the next flow, So the next flow will be sent to AZ2 and so on. So not only it maintains symmetry, but appliance modes also ensure that the load is evenly distributed across your different AZs. I get a question saying like, oh, so we're going in between AZs, so we're gonna be charged inter-AZ cost. And the answer to that is like, when you're going through a transit gateway or a Cloud WAN, there is no inter-AZ cost. So if I'm going from AZ1 on the left to AZ through transit gateway to AZ2 on the right, there is no inter-AZ cost. There's just the charge of the transit gateway or Cloud WAN. On the other hand, if you've got a dedicated dedicated egress inspection VPC, means like just for traffic going to the internet, and you're doing east-west in a different VPC, in that case, you do not need to enable appliance mode there, because you're not doing east-west there. You're just doing egress, and symmetry is maintained or ensured by the NAT gateways, because the NAT gateways will NAT the traffic and will ensure that return traffic will land on the same NAT gateway, the same AZ, and therefore the same firewall. In this case, you want to maintain the default AZ affinity in Transit Gateway and Cloud WAN. All right, so bandwidth considerations, right? Again, this is some of the questions that come up. So we try to be proactive in answering the question that come up frequently in our conversations. So in this case, the bandwidth. So each attachment gives you up to 100 gigabits per second per AZ, right? So it's not the attachment that is 100 gigabit, is each AZ is 100 gigabits per second. So if you have two AZs, you can have up to 200 gigabits per second attachment. That is a lot of bandwidth, right? But I guess in some cases, in very large deployments, some customers might feel that they might need more if you've got thousands of VPCs to the left trying to all get inspected in one VPC on the right. So the way to scale up bandwidth is you could add another AZ, and that will add you another 100 gig, and then your attachment will get up to 300 gig, and so on. And then you because you have appliance mode enabled, appliance mode will ensure that traffic is evenly distributed across different AZs in your inspection. All right. And then now I think it's the last slide before I transition to Joe to talk about Cloud WAN. But this one is a very big one. This one is cost and chargeback. We get that conversation a lot. Every time we talk about inspection, this comes up.
Mehdi, before we jump into the intricacies of cost and chargeback, we do have one question.
Sure.
I think this is a good one. So the question here is, if we are using Suricata rules and TLS inspection from network firewall in conjunction with WAF, right? So I think it's likely for the distributed ingress model.
Mm-hmm.
Does the combination of two give a better protection, or is it just waste of money since the managed rules for WAF already caters the equivalent protection which you get from Suricata for HTTP, HTTPS?
Yeah, that's I think that's a very good question, and it's a question that comes up a lot. So first of all, like when you apply a WAF to your ALB, for instance, the WAF sees an encrypted traffic, right? So your ALB will terminate your TLS and send the traffic to WAF. WAF will inspect it and then send it to ALB, which will encrypt it again. So you got that protection again. So I guess it's very hard to say whether there is zero benefit of having like both a WAF doing the inspection for your HTTP traffic and then adding like a firewall doing IPS, because the reason you'd add a network firewall is just for IPS. You're not going to do it for filtering, because what what would the policy look like? It's coming from the internet, so you'll have like source 000, allow from everyone to come in essentially. So it's literally for the IPS, and I want to say that that the WAF uh, will cover that aspect, but I guess it's probably best to say like just make sure that it covers the aspects that you need.
Yeah, I mean, just to add on, Mehdi, I think the general guidance is WAF should cover most of the use cases, and most of the customers which we work with tend to use WAF for their distributed ingress protection. But then we never know what kind of edge use case you might have or what kind of application you might have. So obviously, every customer's requirements is different. So we cannot say don't use both of them. But in general, yes, WAF alone typically meets many customer requirements.
Yeah, and also consider the cost of like chaining a WAF and then a network firewall and TLS decryption and all that stuff. Okay.
Uh, one more quick question here as regarding the bandwidth considerations. What about the network firewall throughput?
Yeah, I think it said it on the slide somewhere. So the network firewall, each endpoint gives you 100 gigabits per second, the same as the attachment you get from the Transit Gateway. So this little circle here is the attachment from Transit Gateway Cloud One. So that gives you 100 gigabits per second, and this icon here is a firewall endpoint, which also gives you 100 gigabits per second. So if you add another AZ, then you add another 100 gigabits per second as well to the firewall.
Cool.
Cost. So this one, again, as I said, comes up a lot. Pretty much every conversation I have with regards to inspection.
Same.
So one thing you have to know is your charge for traffic coming into the Transit Gateway, right? So as traffic comes in Transit Gateway, that's when we apply the 2 cent charge per gigabyte, right? And usually when we deploy it, is we have like accounts, application accounts and whatnot on the right. And then it's the network and security accounts that would own the Transit Gateway, as well as the inspection VPC, as well as the attachment between the centralized inspection and the Transit Gateway. And then each account is charged for the attachment that they own. So in this case, your application account owners would be charged for traffic coming in. However, traffic getting inspected and returning to Transit Gateway, that is going to be charged to the network and security account, right? So in that case, we need a mechanism to be able to charge back the accounts generating that traffic, because the network and security account does not want to take that charge on, right? So one way to do that, one simple way to do that is what we call a prorating model, meaning you look at the amount of traffic coming through this attachment, right? Work out the percentages, and then divide the cost that you see here to assign to different accounts based on their utilization. So that's good. That's a valid option. It's easy. It works. However, in some cases, let's say where not all the traffic coming from a VPC is going to the inspection VPC, right? So you might end up charging some accounts more inspection than they actually consumed. So in some cases, you might need like a more accurate way of doing that. And there is a way. So one way to do that is to enable flow logs on this on Transit Gateway on this Transit Gateway attachment. So the flow logs will tell you things like what VPC it's coming from, what VPC it's going to, what VPC, the amount of data in that traffic, in that flow, or what VPC it's coming from and what VPC it's going to, and so on. And if you put that data in Amazon Athena, you can get the utilization. So once you get that utilization, you can either multiply it by 2 cents per gigabyte, or you can use your AWS cost and usage report to get a more accurate prediction for the cost utilization per account, and then you can charge it back. You can use a similar approach to charge back for other centralized network services. So if you want to charge back for the firewall, or if you're not using AWS Network Firewall, you're using a third-party firewall, you want to charge back for NAT gateway, or if you want to charge back for the traffic going to the internet, you can use like a similar approach. Just one note here, Cloud One does not currently support flow logs. So you have to look at either using like the prorating model that I mentioned earlier, or maybe look into doing it with VPC flow logs, which is going to take you a bit more work than the Transit Gateway flow logs. And that's it for this section. Before I move on to Joe to talk to you about Cloud One and service insertion, are there any questions on costs, chargeback?
So on the cost part, there is a question. Do we already have any solutions which we can deploy, which will use Athena or Cur?
Which we use, sorry?
Athena or cost usage report. Is
Yeah.
there any solution already exists which which they can use?
Yes, there are. This is like a solution that is widely deployed, and you can find the samples for it published already.
Okay, awesome.
And there's also like blogs about it and so on that will give you all the details step by step on how to do it.
Cool. So there are two questions which I'm going to quickly answer in interest of time. The first question is, can we do firewall endpoint in remote VPC like gateway load balancer endpoint? The answer is yes. You can have a endpoint in one VPC pointing to a firewall in your different VPC. And the second is, so the network firewall will auto scale to handle traffic, just to make sure I understand well. That is correct. The network firewall is based on a scalable compute infrastructure, which automatically scales up and down based on your customer traffic.
Just on the first question, I'm not sure I understood it, Sid, correctly. Is the question asking whether the AWS network firewall can be deployed in multiple VPCs like gateway load balancer?
It specifically says firewall endpoint.
Yeah, I mean, for now, today, AWS network firewall is a one-to-one to a VPC, so it can exist only in one VPC. So that's the difference between that and gateway load balancer, which can be deployed in multiple, can have endpoint in multiple VPCs. If I'm understanding the question correctly.
So just so that it's clear. So let's say you have this model where your network firewall is deployed in a VPC. Well, you have a network firewall, right? That firewall endpoint can only exist in one VPC.
Yes.
Oh, interesting. Okay, so it's not like gateway load balancer.
No. At the moment, it's like that. Yeah.
Okay. No, thanks for the clarification there. I think that was the question.
Okay.
Awesome, Joe. I think you are all set.
Okay, thank you. So let's talk Cloud WAN service insertion. So what is service insertion? Service insertion is a new feature. It comes, I think, came out last June. Yeah, it allows you to insert your third-party and AWS native firewalls into the path of the traffic. So what that does is it greatly simplifies because of the centralized architecture. As I mentioned, it's easy insertion between your third-party and your AWS network firewalls. And this can be done on a global scale because Cloud WAN is a global feature. It's a global service. So how does it do that? It does that with what we call a network functions group. And basically, a network functions group under the hood is a Cloud WAN segment. It consumes one of your segments. It contains all your firewall and all your security attachments. The routing there is fully managed. No need for static routes. If you did it in the past, it's dynamic. And you still have full visibility into the routing. You just look in the console and you would click the network functions group and you can view all the routes that it sees there as well. So how do we do that? It's the same as any other segment. Basically, you create an attachment policy and you tag it, except this time you're going to tag it with a value of NFG and maybe a key environment. And all your inspection VPCs in each region will attach to that network functions group. At that point, the routing becomes dynamic, right? As I mentioned. So when you do we talked earlier about ingress, egress. If you need to do that, you would do what we send to action in the policy statement. And what that does, it originates default routes. So as you can see here, we have a V4 and a V6 default route pointing to the inspection VPCs in each region. In the past, what you would see in green here had to be all static and per region. And then we talked about east-west, so cross-segment traffic. That's done by a send via. So I think there was a question earlier by Ken. He mentioned QA and prod. You would do prod to QA would be send via. And again, it's an all or nothing type thing there. But again, what that does is it propagates now all the routes and all the VPCs in the regions into that network functions group. So it sees all the routing. Again, what you see in green here would have been in static routes. And so you have more regions, you have to add more static routes, you add more VPCs and more CIDRs, more static routes. So it's a lot of admin over. This greatly simplifies that. So some of the benefits, it's on a global scale, as I mentioned, right? So it's a global versus transit gateway deployment, which is regional. Single hook insertion, as I said before, you just insert your firewalls right into the path of the traffic. Dynamic versus static routing. I mean, that's a huge one. We talked about send to and send via, but let's talk quickly single hop and dual hop. So I'm just going to go back a slide. I can show you here on the drawing. So if you look, we have two regions, inspection VPC in region 1, inspection VPC in region 2. If we had a source of a VPC A and a destination of VPC D, dual hop is what we used to do. So it would send traffic to the inspection VPC in region 1, and then from there to the inspection VPC in region 2, dual hop. And then finally the destination VPCD. So we listened to our customers and they said that's a little bit more overhead, a little bit more latency. What can we do? So we came up with single hop. So single hop will choose one of the inspection VPCs in the region, and it's based on a priority. You can set the priority, but let's just say for argument's sake, it's default priority. US East 1 has the highest priority. So we'll say US East 1 is on the left and US West is on the right. The same flow, VPC A to VPC D. So A will send it to inspection VPC in region 1 because US East 1 has the higher priority. And then from there, it'll go to the destination VPCD. Now the reverse flow, let's say D is the source and A is the destination. D is going to send its inspection traffic to the region 1, US East 1, because of that higher priority. And then finally the VPCA as the destination. If we're going from C to D, it will choose the inspection VPC in the region. So that's single and dual hop. Let's quickly go to service insertion considerations. So you can have multiple network functions group for core networks. I have many customers that do that. However, you can only have one network functions group between a segment pair. And an NFG cannot be in both single hop and dual hop mode. So you would have to create another network functions group, put one in single hop, put one in dual hop. So as I mentioned earlier, we listen to our customers, and now with service insertion, there's an issue with out-of-band management where because when you attach the VPC to the network functions group, the CIDR ranges are not automatically advertised anywhere. So this applies with gateway load balancer. AWS Network Firewall managed service, so it doesn't have that. You manage it in the back end. But if you're using a appliance with gateway load balancer, we came up with a workaround for that. So what we do is this approach using two VPCs, right? So I think one of the questions earlier was, can we separate the endpoints? Yes, as you see here, we separate the endpoints from the gateway load balancer. and the appliances are in the same VPC, the management VPC. We still have our inspection VPC. It's attached to the network functions group. Traffic flows to the endpoint, but the endpoint is now using private link to communicate with the gateway load balancer, and the gateway load balancer has its target groups here with your third-party firewalls. So that simplifies getting it. It also separates your data plane from your management plane. So it gives you a little bit more security. So we can say VPC A is attached to the management segment. It has a route because it's attached to the VPC with the management. VPC B doesn't have that, so it's not going to see that. Again, it's a little bit more secure, and it separates your data plane from your management plane. Now, I'm in the process of writing a blog on this. There's actually two other approaches to this. I don't have slides on it, but I'll briefly touch on them. So the second approach is basically using multi-VPC ENI, right? So you would basically put two VPCs, put an ENI in one VPC and one in the other. The third approach is manually adding static routes. We don't suggest that. You can do that, but what you would need there is you have to have routes for every inspection VPC, and you have to apply those routes across. So if you want some more information, that blog will be coming out shortly. Just look for it. It's out-of-bands Cloud WAN management. Any questions there, Sid, on the Cloud WAN?
Yeah, we do have one question. Is it mandatory to have a firewall in each region? Can we do region 1 to region 2 inspection through a region 3 firewall?
Yeah, I believe you can. You could do I forget what it's called, edge override.
Edge overrides.
Yeah. Override, yeah. Yeah, so you can pick the region you want your inspection to be done in. So in that case, you could certainly choose region 3. I wouldn't suggest it because then you're sending your traffic across regions. You pay a transfer fee, and you might have some latency issues going across the regions, but I wouldn't. It works nonetheless.
Cool.
Any other questions?
Don't see any other, so we are good to continue.
Okay, so that's it for Cloud WAN. Mehdi's going to talk firewall policy. I think we're almost out of time too. So
yeah, I'm gonna do that very quick. And I'm gonna take 2 minutes to do this. So just when you centralize your firewalls, you have to think about your firewall policy. So one thing to keep in mind is you need to keep it simple and easy to manage. And how we would do that, first you want to just start by using Suricata rules if it's an AWS network firewall, always. It just makes it easier to manage and a lot more scalable. You want to use things like variables and IP sets to define your IP ranges. Try to avoid putting IP addresses in your rules. So if that change, you don't have to go and revisit your rules because you have variables. You can just modify your variables and IP sets, for instance. It just makes it easier. And thirdly, plan your IP space, right? So make sure you have your IP plan done properly. So have blocks per region, blocks per environment, blocks per account, VPCs, and so on. It's going to make your security policy a lot more compact and easier to manage and read. So I've seen where the IP plan is not managed properly and the security policy is all over the place. It's like tens of thousands of lines, right? Also, don't use your centralized firewall for microsegmentation. You've got security groups. Don't forget, you can use those for instance-specific rules. Use your centralized firewall for broader security rules. If you see that your security policy is getting too long, too difficult to manage, maybe consider splitting your egress and east-west because they tend to have different requirements for policy. So you might consider that option. 4, I think, is very important. So find a process for developer to request rules, right? So that's the customer that actually succeeded in centralizing inspection is customers who have an automated process where developers can easily request a rule. Very simple. It's either automatically deployed, or it gets approved first and then deployed automatically. Right, you have to minimize human intervention in this case. Also, for cost, try not to send all your traffic to the network firewall. Think about things like route tables or Cloud WAN segments, which give you segmentation. You can separate environments like prod and non-prod. Think about using VPC endpoints or gateway endpoints, so you don't have to send your S3 traffic to your firewall, and so on. So think about not sending all traffic to inspection, and in the same context, think about DNS firewall, using DNS firewall, which stop the instant sending traffic in the first place by blocking it before traffic is initiated, right? If it's trying to go to a destination that is not allowed, don't wait for the traffic to go to the network firewall to block it. You can block it at the DNS level. That's it. Stopwatch, 2 minutes. I'm done with this one.
All right. So we do have one question.
Uh-huh.
I know, Mehdi, you have been talking about this managing firewall policies, but would you use Firewall Manager as your central tool to do all of this?
Yeah, 100%. I mean, as your environment grows, if you have like more firewalls, and you're gonna have WAF, and you're gonna have like Shield Advanced, and you're gonna have security groups, and you're gonna have ACLs, and you're gonna have DNS firewall. Yes, Firewall Manager will definitely help you with that.
Okay, awesome.
Okay.
I don't see any other questions. We do have 5 minutes remaining. So, Joe, anything else you wanted to add?
Yeah, I have one slide. We can talk logging and monitoring, right? So
Cool.
logging and monitoring, very important, right? You want to be able to see and you want to be able to know what's going on in your network, right? So you definitely set up monitoring, set alarms. You can use CloudWatch metrics for that. So we can use CloudWatch metric options for a number of things. We can do it with Network Firewall, or if you choose a third party, you can do it with Gateway Load Balancer. If you deploy it on Transit Gateway, we have metrics. If you do deploying on Cloud WAN, we have metrics, right? Enable your firewall logging, whether you're using AWS or you're doing third party, enable it for your firewall logging. And if you're using AWS Network Firewall, you can set up alert logs. So you can send alert logs for rule actions, drop, alert, reject. But we also suggest setting up a rule alert for a pass. Right. This way, you know it's getting passed through your network, not only just what's not being allowed as well. And then finally, CloudWatch Contributor Insights. It's a very useful tool. You can use it to analyze. You can use it to visualize. You can create dashboards with it. You can view your top blocked domains, and you can view top blocked clients by managed rules as well. So that's it. We made it through.
Yeah, I just want to add something on the logging and monitoring, Joy, which you just mentioned.
Sure.
I know we don't have time, so we have only one slide on it, but it's very, very important. I see a lot of customers deploying like things like egress inspection or east-west inspection just for visibility because they need to see what
Right.
traffic is going from their environment to the internet, and therefore they do it via this logging.
Awesome. So let's just go through some closing thoughts as we
Mhm.
wrap this up. I'll just quickly share my thoughts. Absolutely fantastic presentation, Joe and Mehdi.
Thank you.
And as I was going through this, there's a lot here. And the one guidance I would give to the people watching today is, you have distributed firewalls, centralized firewalls. Then we talked about cloud WAN, segment, service insertion. Maybe you mentioned, hey, only send traffic to the firewalls which needs to be inspected. Try to use security groups, try to use network isolation, try to use DNS firewall. So it looks like we have a lot of security tools and at different layers. So it gets really important for customers to really understand, what's purpose built for which use case, and then use the right tool for the right job, right? I think it's important not to, we had questions, should I use WAF and network firewall together? So it's important not to drink the Kool-Aid and try to over engineer your network security with all the different possible tools, because that's going to be expensive. Chargeback is going to be difficult. It's going to be high latency, etc. So I think today's presentation was really good, giving you the pros and cons of all the different choices, so you can make an informed decision. So that's what I took out of it, and it was really good.
Yeah.
Mehdi, Joe.
Thanks, Sid. I think
Thank
that's
you.
exactly what we try to do. We try to have like an opinionated view of how to do things based on the conversation we have with our customers. So I'm glad that that came across. Thank you.
Yes, there's a lot of options, Sid, as you mentioned, and we covered quite a bit today. And we tried to stay higher level, but we can certainly go deeper if we need to. Just reach out to your account managers, and we're here to help.
Perfect. All right, folks, that was the end of our session. Thank you for joining. As I said, we do this every week. So next week, we'll come back at the routing loop and talk about something different within the space of AWS networking. I appreciate everyone joining and have a great day.